Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on the empirical rule. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint in making this set of videos. This is part 2 on this PowerPoint. In part 1, I went into detail describing the curve and how it's set up. In this part, I'm going to quickly review the empirical rule and work in an example. 68% of the data lie within one standard deviation of the mean. So we would have 68% of the data within one standard deviation of the mean. 95% of the data lie within two standard deviations of the mean. So we have 95% in between two standard deviations. 99.7% of the data lie within three standard deviations of the mean. So we would have 99.7% of the data within those three standard deviations. This is essentially all the data. But remember, bell-shaped curves theoretically go on forever to the right and to the left. This is called the empirical rule for normally distributed data. The empirical rule for normally distributed data tells us that 68% of the data lie within one standard deviation of the mean, 95% lie within two standard deviations of the mean, and 99% of the data lie within three standard deviations of the mean. And someone a lot smarter than I came up with these percents. You will need to memorize these 3% for your course here at Walter State. We can use those percents in the empirical rule to answer a variety of problems. Here is an example for us to try. The weight of candy apples is normally distributed with a mean of 6.76 ounces and a standard deviation of 0.04 ounces. And we have parts A through C, and we're going to look at part A. The middle 95% of the candy apples lie between what weights? Well, before we get started, since we're dealing with a mean and a standard deviation, let's draw our curve. Let's place and remind ourselves what the mean and the standard deviation are. Let's place the mean at the center line, and let's count up our standard deviation of 0.04 and add that to the mean once, twice, and 3 times. That will give us 6.80, then 6.84, and then 6.88, and that gives us our 3 standard deviations above the mean. We can then go to do below the mean by subtracting the standard deviations. One standard deviation below the mean would be 6.72. 2 standard deviations below the mean would be 6.68. And 3 standard deviations below the mean would be 6.64. I have said before, and I will say again, that a picture is worth 1,000 words. This is especially true for the empirical rule. This way, we have actually found all of our answers for A through C before we begin, and we can just look at our chart or our table or graph here to find them. Now, back to what part A asks us. The middle 95% of the candy apples lie between what weight? Well, remember our empirical rule. Our empirical rule uses the percentage of 95%. At 95%, it lies between two standard deviations to either side of the mean. So if we will go back and look at our graph, where we graphed and labeled it, we need to think about 95% and shade two standard deviations from the mean. And notice our two tick marks, and if we will jump out those two tick marks in either direction and shade, that will be 95% of our data. That then gives us 6.68 and 6.84 as our answer, and we can answer that the middle 95% of the candy apples lie between 6.68 and 6.84 ounces. Part B says what percentage of candy apples lie between 6.64 and 6.88 ounces. In this case, it gives us numbers. So let's look at our graphs and circle those two numbers. 6.64 and 6.88 are symmetrical from the center. They are both 3 standard deviations from the mean. So since we know they are 3 standard deviations from the mean, let's go back and look at our empirical rule. Since we know they're 3 standard deviations from the mean, that tells us our answer is 99.7. So we can come back and put our 99.7 in our graph, and we know the answer then is 99.7% of the candy apples lie between 6.64 and 6.88 ounces. Part A and B are really easy to do once you have drawn your own chart. Part C is a little bit more of a challenge. What percentage of candy apples weigh less than 6.84 ounces? Well, again, let's go to our chart with our numbers on it, and let's shade below 6.684. There's 6.84, and let's shade below that mark. But how can we figure this out using the empirical rule? Below 6.84 is not between any two sets of standard deviations, so it cannot use the empirical rule directly. Let's go back and think about the bell curve's symmetry. Within one standard deviation, we have 68%. If we take half of that, because it's symmetrical, that means each side is 34%. We have a pink side and a green side shown here, and since they're the same size and shape, each side will be 34%. For 2 standard deviations, that's 95%. And half of 95 would mean each side would be 47.5%. And at 99.7 for 3 standard deviations, each side would be half of 99.7 or 49.85%. So we can use the halves to find and know what each side of those. Notice you do not need to memorize these percents, you just need to know that they're half of the original 3%. Also, we have 100% of the data, and half of that would be 50% on each side. So, what percentage of candy apples weigh less than the 6.84? Well, since we cannot do this directly, let's divide it into the symmetrical pieces. Let's divide this into two parts. As you divide it into two parts, we can see that it shades forever back to the left. So let's shade that as a 50% piece, as a shading back from the center line back. Then the other piece will be from 6.76, the mean, to 6.84, which means it's half of a 2 standard deviation jump. So that means we have a half of 100% and half of a 95%, because that's a 2 standard deviation jump. Once we know what the two pieces are, we can add the 50% to the 47.5% and get a total of 97.5% that we've shaded. Once we know that, our answer then is 97.5% weigh less than 6.84 ounces. Here are some exercises for you to try. Remember, as you do those, for those that cannot be used directly with the empirical rule, to divide your shaded area that you're looking for into puzzle pieces and to use symmetry to find the puzzle pieces that you've divided it up into, like we did in Part C. Thank you for watching this set of videos on the empirical rule. And as always, if you need help, please come by and see me in MBSS room 222, the Math Lab. Thank you.